3.5 Rational Functions and Their Graphs Preparation. Now, in this case right here, whenever we try to factor the denominator, we can't factor this denominator. It does have a perfect square here. And 9, you can take the square root of 9, which gives you a 3. But since it has a plus in the middle instead of a minus, you can't factor this. There's no real factorization of this, right? Nice, not a nice one. Now, what that means is you're not going to have any vertical asymptote, and you're also not going to have any holes because there's no limitation on the domain because nothing will make the denominator equal to 0, no real number, right? So that one's actually almost a trick question. All right, so we went over vertical asymptotes. Let's go over horizontal asymptotes. So the definition of horizontal asymptote is basically the same, except now instead of you approaching positive and negative infinity, now you're going to be approaching positive and negative infinity along the left and right, along the x-axis, right? So horizontally, you're going to be approaching infinity. Okay, so I'm just going to skip over all of the algebraic gobbledygook, and I'll do some examples. Let's do some examples. Now, what we want to know is they're talking about the n, and I'll come back to this. There's only 3 possibilities. They have n and they have m right here, right? Now, n is the numerator, and m is the denominator. And what they're basically saying is if n, right, there's 3 possibilities compared to m, right? That's what they're talking about, if that makes any sense. Okay, now the first possibility that has what happens if the numerator is bigger than the denominator, right? So basically, you know, big is on top and small is on the bottom. Okay, so they say if the exponent, right, these are the exponents, n is the numerator's exponent, whereas m is the denominator's exponent. If the numerator's exponent is, sorry, this one says smaller. Got it backwards. So the first example is where it is in fact smaller. So we'll go with that. Okay, so in this case, they're saying the numerator is smaller, so it's small. And then this one's big. All right, and these are comparative, bigger, smaller. All right, so what happens in this case is the horizontal asymptote is at 0. Okay, so you can kind of think about this pulling it down to 0, right? So the numerator is trying to pull up, but the denominator is bigger, so it just slams it down, right? It just slams it down to 0. So you end up with y is equal to 0. That's the first case. Now the second one, well, I'm going to skip over to 3. Okay, so what happens if it's bigger on the top? It's bigger and it's smaller on the bottom. Well, you can kind of imagine the one on top just kind of pulls it up. The bottom one tries to pull it down a little bit. They can't really do a very good job. So in this case, there is no horizontal asymptote, right? The numerator just lifts off. It's not pulled back down by the denominator, right? So it just whoosh, goes up to infinity. There's no horizontal asymptote on this one. Okay, now you'll get into limits. This concept might make more sense later on when you get to limits if you go that far. Now the middle one is if they are equal, right? So same. In this case, what you're going to do is they're saying, you know, if you have an over am, right? But these 2 exponents are the same. What you do is, sorry, that needs to be a b. That needs to be a b. What you're going to do is you're going to make a coefficient. You're going to make a fraction out of the coefficients, right? Okay, so let me actually do these examples, and hopefully it'll make more sense. I know that's still a little bit abstract, so let's do a couple of examples of this. So let's look at the first one. So this has a 1 exponent on top and has a 2 on the bottom. So it's small on the top and it's big on the bottom, right? Bigger. It's a comparative thing, bigger, right? Okay, so what that means is we know that that denominator is going to pull it down to y is equal to 0. That's the asymptote. Okay, let's look at the next one. The next one, if you notice the exponents, they're the same. They're the same asymptotes, right? So same. Okay, so what we're going to do here is we are going to take their coefficients, the 4 on the top and the 2 on the bottom, and that gives me a 2. And what we're going to say is, well, that means the asymptote is at 2. Okay? Let's try the next one. Now you can also compare this to the graph, right? So there's a 0, which means you can see it approaches, on the left side, it approaches as it goes towards the left, but never quite touches it. It goes through here. It looks like there's probably a hole right there. And then it goes up, and then it goes in, approaches again, the y is equal to 0 in the middle. Over here, y is equal to 2. You can see it approaches, going from the center to the left, it approaches it. Going from the center to the right, it approaches again, but it never quite touches it. If you kept zooming in, there's always be a little space in between the graph and the y is equal to 2, this line right here. Okay, so let's try the next one. If we look at this one, let's see what we have here. So this one right here, we notice that there's a 3 exponent on top, and there's a 2 exponent on the bottom. And this one does not have horizontal asymptote. There we go. So this one, it may look like there might be it approaches, but it just kind of goes right on through here. It does go right through. There's no hole. There's nothing. It just goes right through there.